there are a few nice algebra tricks that we can combine with the limit laws to calculate some tricky limits. So here are a few examples. For our first example, let's find the limit as x goes to 8 of x minus 8 over x squared minus x minus 56. This is one of those tricky examples where if you just tried to plug in 8 for x, you'd actually get 0 over 0. So this is kind of a problematic example if we didn't know anything else about limits. But we do know more about limits. So you might try using the limit laws right away and writing the limit as x goes to 8 of x minus 8 over limit as x goes to 8 of x squared minus x minus 56. But as I said a second ago, if you find this limit in the denominator, it actually comes out to be 0. And the quotient rule for limits explicitly says that if the limit of the denominator is 0, you can't use this limit law. So we have to come up with some other way of approaching this limit. Well, one thing that we can do is we can do algebra on this expression before trying to evaluate the limit. So let's leave the limit alone for the moment, limit as x goes to 8, and let's just think about what sort of algebra tricks we might use for this kind of expression. Well, this expression it's a rational expression, so one thing we might do with it is we might factor it to see if anything simplifies. So the numerator is already factored because it's degree 1, but the denominator, it looks like it's x plus 7 times x minus 8. But now that we have this factored, we should be able to simplify this ratio, right? This x minus 8 we should be able to simplify this rational expression by just getting rid of the factor of x minus 8. But we have to be a little careful because we can't just ignore the fact that x minus 8 is there. So it's 1 over x plus 7 times x minus 8 over x minus 8. And what we'd like to do is say that, well, x minus 8 over x minus 8 is 1. Except x minus 8 over x minus 8 isn't always equal to 1. It's equal to 1 if x isn't 8. Right? If x is 8, then this is 0 over 0 and everything blows up in our face. But remember that for a limit, for the purposes of finding a limit, x never gets to this value. So x isn't actually equal to 8. It gets very, very close to 8, but it's not actually ever equal to 8. And as long as x isn't equal to 8, this ratio is 1, so we can simplify those. So you see that the fact that we're taking the limit is what lets us do this simplification. So now we have the limit as x goes to 8 of 1 over x plus 7. And now we can use the limit laws, right? Something that you probably noticed with the limit laws is that for polynomials and rational expressions, I wrote infinity instead of 8. For polynomials and rational expressions, you can just plug in this number and you'll get the appropriate limit. So this is 1 over 8 plus 7. Well, as long as it doesn't make the denominator 0, you can plug in that number. So this is 1 over 15. All right. Nice. So the algebra trick that we used here is factoring. And what we are doing by factoring is just checking if, because we got 0 over 0, we were checking if factoring let us simplify the expression. Okay, this is going to be in the way. Now let's look at our next example, limit as x goes to 2 of x minus 2 over the square root of x plus 2 minus 2. So as with our previous example, if you try to just immediately use the limit laws with this one, you get 0 over 0, which means that you can't actually use the limit laws. So we need to come up with some other algebraic trick to use before we start thinking about using the limit laws. So what sort of algebraic trick can we use in this situation? Well, you might have seen, or having a square root in the denominator like this might make you feel suspicious. There's an algebra trick for this situation. It doesn't always help, but it's at least worth trying since we're out of other ideas. The algebra trick for this situation, when you have a square in a rational expression, when you have a square root that's part of a sum or a difference like this, what you can do is multiply the numerator and denominator by exactly the piece with the square root, so square root of x plus 2, and then a minus 2, except instead of a minus, we'll put a plus. It would be fair to ask, why are we doing this? But you'll see in a second that what this is going to do is clean up the square roots a little bit. Well, if we multiply by this in the denominator, we have to do the same thing in the numerator. So square root of x plus 2 plus 2. All right, so this is the limit as x approaches 2. Now, in the numerator, there's no real need to actually multiply out this stuff in the numerator. So let's just leave this as x minus 2 times the square root of x plus 2 plus 2. Now in the denominator, we do want to multiply out the denominator because it's going to make the square roots go away. So square root of x plus 2 times square root of x plus 2, that's x plus 2. And then root x plus 2 times 2, that's plus 2 root x plus 2. And then minus 2 times square root of x plus 2, that's minus 2 square root x plus 2. And then minus 2 times plus 2, that's minus 4. All right, now you can see that by multiplying out this denominator, these cross terms cancel. And now there's no square root left in our denominator, which in general might be nice for some reason. But in this particular example, it's actually extremely nice. So the numerator is now x minus 2 times the square root of x plus 2 plus 2. And the denominator is x plus 2 minus 4, that's x minus 2. So now we can simplify this even further. So we're taking the limit as x goes to 2 of the square root of x plus 2 plus 2. And now we can use the limit laws to work on this limit. So this is the limit, it's the square root of the limit as x goes to 2 of x plus 2 plus the limit as x goes to 2 of 2. So this is the square root of 2 plus 2, that's 4, plus this limit here is 2. So 2 plus 2, it's 4. The whole thing is just 4. All right, so this algebra trick here, this is called multiplying by the conjugate. And if you get a 0 over 0 situation that has a square root in it like this, often multiplying by the conjugate will let you make progress. The conjugate, this process of flipping the sign in the middle, that's called conjugation. So that's why this is called a conjugate. All right, so now we have a trick for rational expressions. We have a trick for when square roots show up. What about something like this? Limit as x goes to 4 of 1 over x minus 1 over 4 all over x minus 4. Now, as usual, so all of the interesting limits give you 0 over 0 when you just plug in your value, and that is the case here. If we try to use the limit laws immediately, we're just going to get 0 over 0, which means that we can't use the limit laws. So we need to do some algebra first. What sort of algebra could we do? Well, this numerator catches my eye because it's a difference of fractions. So we could actually put these fractions over a common denominator to see what we get when we subtract them. So this is limit as x goes to 4. Our denominator is going to stay x minus 4, but in the numerator, we need to make a common denominator show up. So we need a 4 here, and here we need an x, like this. So this gives us the limit as x goes to 4 of 4 over 4x minus x over 4x over x minus 4. Now we can actually do this fraction subtraction here. So we get limit as x goes to 4 of 4 minus x over 4x over x minus 4. So this is the limit as x goes to 4. So I don't like having a fraction inside of a fraction here. That's messy. So what I'm going to do is take the numerator and sort of slide it off to the side. That's a trick you can always do with fractions. So 4 minus x over 4x times 1 over x minus 4. And now it might look like nothing simplifies any further, which is still a problem, because if we use the limit laws, we get 0 over 0 again, which isn't helpful. But in fact, we can simplify this some more, because this piece right here, 4 minus x, that's the negative of x minus 4 over 4x times 1 over x minus 4. And now we see that these x minus 4 pieces simplify away. So we're left with the limit as x goes to 4 of negative 1 over 4x. And now we can use the limit laws to evaluate this. Of course, since this is a rational expression, it's actually just safe to plug in this x value. We get minus 1 over 4 times 4, that's 16. So minus 1 over 16. As a final example, remember that finding this limit is one of the situations that inspired us to start calculating limits to begin with. So we looked at a graph for this. I think I still have it here. Not that one, this one. Right? Here's the graph of that function, and when we zoomed in far enough near 0, it looked like the limit didn't exist. But now we have some extra tools that we can use to evaluate limits exactly, so let's use those tools to see if this limit actually exists or not. Because of the square root here, it seems like we should probably use our conjugate trick, so let's multiply by square root 4 plus x squared, and then instead of a minus, we're going to have a plus 2, and then we need to do that in the denominator as well. Square root 4 plus x squared plus 2. So we get the limit as x goes to 0 of, now the denominator, let's not multiply it out. Let's leave it as x squared times the square root of 4 plus x squared plus 2. And in the numerator, let's multiply this out. So first times first gives me 4 plus x squared. First times last gives me plus 2 root 4 plus x squared. And then last times first gives me minus 2 square root 4 plus x squared. And then minus 2 times plus 2, that's minus 4. Okay. Now these cross terms in the middle, they're negatives of each other, so those simplify away. And also we have a plus 4 here and a minus 4 there, so these also simplify away. And now we actually aren't done simplifying it. I'm going to rewrite it just to sort of clean things up. So limit as x goes to 0 of x squared. X squared is the only thing left in the numerator. And our denominator is x squared times the square root of 4 plus x squared plus 2. And now we see how the x squareds also simplify away. So now we're left with the limit as x goes to 0 of 1 over root 4 plus x squared plus 2. All right. And with this expression, it's safe to start using the limit laws. So the denominator won't give us a 0. So if we use the limit laws, we get 1 over square root of the limit as x goes to 0, 4 plus x squared plus 2. And when we plug in the 0 here, we get square root of 4 plus 2. So this is 1 over 4. Which, if you remember to a previous video, this is actually the value that we guessed for this limit before we zoomed in. So it turns out that our initial guess was right.